I'm Chris Allen. I'm CEO and co-founder of Red 5. And I'm here to talk to you a little bit about live streaming and how it relates to IoT, or Internet of Things. First and foremost, just a little bit of a background. We started the open source Red 5 server, and that involved reverse engineering RTMP, which is the Flash video streaming protocol. And RTMP is continued to use throughout today. And basically, this server took off to the point that it made sense to create a consulting company around it, and that's what we started back in 2007. And ever since then, with Flash going away, we saw that as an opportunity and started building a pro version of the server that allows people to use more modern devices and do these kind of streaming experiences, similar to what we're doing here with this conference app. But of course, what's more interesting is how you can relate it to doing live streaming. So let's quickly go through, and let me see if I can get my slides going here. All right, here we go. As I said, I'm Chris Allen, co-founder and CEO of Red 5 and Red 5 Pro. And we were the first team to reverse engineer RTMP and create the open source Flash media server called Red 5, which competed directly with Adobe Media Server. And now today we've got a very robust platform for building things that are other than Flash, including iOS, Android, HTML5, and IoT. And the first thing I wanted to get into really is that IoT, even though it's considered a really new thing, IoT and video isn't really that new. You have everything from this, video telephone type thing, which sure it wasn't exactly the internet, but it was connecting over the internet with a thing, or connecting over the wires with a thing and allowing video to happen. And my company has worked on things ever since 2007. This is a sensor from a company called SICK out of Germany. That sits on top of conveyor belts in shipping industry. And we were building live streaming software for this with Flash and scanning packages in real time and allowing people to see that data and manipulate it. And it was all connected over the internet and allows people in a central repo to see what's happening. And we were also using video cameras with this so they could see the actual packages flowing and see, inspect it, rewind back in time, and doing really cool stuff. And we started this project, I think, in 2008, and it's still being used today. We also worked on this kind of smart batting cage, which was a pretty cool project for baseball players. They would have these force plates and cameras inside of it that would actually analyze what's going on with your throwing or your swinging or what have you. And that was also connected to the internet in a pretty unique way. And then this project that we did with Trafficon, which later got acquired by Fleur, we were using these IP cameras that were sitting above highways, like this thing here, and that would be then transferred over to an interface that a person, who's controlling or monitoring traffic in the city would be able to see in real time. And that was also done with a Flash interface, back about 10 years ago. And all of this was done over RTMP. And what we're seeing now is kind of more of a move to WebRTC. And my screen and my voice right now are actually being delivered to you guys over the WebRTC protocol, which allows for some really interesting experiences, particularly when you add in devices. So speaking of protocols, let's just go through. I like to kind of divide them into two categories. One is like the high latency video streaming categories. And keep in mind, I'm focusing on kind of the more modern protocols. High latency usually means they're HTTP based. The HLS is Apple's protocol. It's pretty much universal across the board. Almost every browser supports it. But what's inherent in both the MPEG Dash and HLS is that it's downloading segments at a time. And in order to do that, you have to divide up your segments by keyframes, and you have to have about 3 in the queue at any one time. So that usually means that at the best, you can get it down to maybe 4 to 6 seconds of latency from end to end. But typically, if you go through like a CDN or something like that, then you're looking at more like 30 or 40 seconds. And, for anything that's really live or interactive, it's just not going to work. So then you got to look at other protocols like WebRTC, RTMP, which I've already mentioned, or RTSP to be able to create kind of low latency, real-time experiences where you can have video communication or controlling a drone, for example, or doing all kinds of other things with it. And then the other thing to consider is the peer-to-peer model versus a client and server model. And they both have their advantages. My company tends to focus mostly on client-server model because there's a lot of kind of software out there already that does P2P. And the more interesting stuff, I think, actually is when you stick a server in the middle. So peer-to-peer, it does use a server, usually, especially with WebRTC, for signaling. It'll actually pair the device. It'll say, hey, this device is available on this network over here. I want to connect to this device over here, and then this server will take care of routing it, and that's called signaling. But then the media itself is passed directly in a peer-to-peer fashion, and that could, these are 2 smartphones kind of represented here, but this could be a camera of some sort on a robot maybe, and going and connecting directly to the device. This has a lot of advantages. You don't have the overhead of bandwidth on the server. You don't have to deal with the complexity of setting up a media server in the middle. But the downside of that is it doesn't scale very well. If you start getting everybody to add a peer node to this, then you've got all these connections happening. It starts to break down after about 6 or 7. And on low-powered IoT devices and phones and things like that, it's even worse because they just can't handle that many connections all at once and all that data coming in. So you're better off throwing a server in the middle, allowing it to do some of the processing and combining of the streams, or if you're doing things like recording, you need to record the streams like we're doing with this session right now. This is being recorded up on a server. And, quite a few other scenarios. Maybe you want to process the images as they're coming through or transcode them into another format so that, you might have a device that's speaking WebRTC, but the camera you have only can stream RTMP, or maybe it's RTSP. So a server in the middle can actually alleviate all of that. So just quickly, what kind of IoT devices are out there that are typically being used for streaming video? It actually essentially boils down to anything with a camera. I think even on the flip side, anything with a screen is also a possible receiver video, so that the possibilities are pretty endless. That said, I'm just going to go through some of the most common ones we're seeing today. Obviously, drones have cameras. This is probably the most common and obvious use case. Robots with cameras, IP security cameras. This is a body-worn camera. They're kind of a body cam that police use. Typically today, it's mostly used for kind of evidence and video recording and after the fact kind of thing. But now they're starting to look into what would happen if this body cam is online and they can see the live video coming through. That opens up a lot of different possibilities, and could actually be a real help to law enforcement, military, or other use cases, emergency responders. There are also kind of these encoder boxes. This is a matrix box, which will encode an RTMP and send up to a server. You can just plug in a camera into the device, and it'll start streaming it out. And then, of course, glasses. Google Glass apparently isn't dead. I think they just didn't get the right idea that consumers aren't going to probably be into that, but it's definitely a popular thing in kind of industry where you might have a technician looking at a piece of equipment, which is very complex, but then has an expert on the other end who could actually help troubleshoot that. And we're seeing some use cases of this today as well. So specifically, use cases that our customers are seeing and using Red 5 Pro for. Speaking of the helmet-mounted webcam, Ericsson is actually using it for their Show It app. And this allows a technician, just as I was saying, to talk to an expert who is remote and can help troubleshoot their people who are in the field. And in this setup, it's using helmet-mounted Sony Action Cam, and then that's actually using the Android device or a phone to consume the video over its Wi-Fi hotspot. So the phone's connected over Wi-Fi hotspot, and then it's streaming over its 4G LTE antenna. It's actually not 5G, not yet anyway. And then it streams it remote to a technician who's viewing it via an HTML5 app with WebRTC. And then this guy's audio is coming back, and then he can hear the audio in the Android device. And this allows for a two-way communication. It also allows for other people to view this person's stream, so it's not just one-to-one, but it can be one-to-many as well. We're also seeing other companies using it for home security or surveillance, or any kind of like use of an IP camera where you need to get real-time communication with it. In this case, IP cameras in a house. It's connecting to a Red 5 RTSP client and running on the server. Now that sounds confusing, but almost all IP cameras run RTSP servers, and so in order to connect to the server, you have to be a client. So it's actually the server making a request into the camera and then relaying the stream out through the rest of the pipeline. It's also pushing the raw H.264 video data into Hadoop, in this case for storage, and then it can pull out specific VOD as it's needed, or it can actually pull the live stream to push it to another Red 5 instance, which is an edge server, and then it can stream it to anybody who wants to view that stream. And then we also have this concept called the stream manager, which actually takes care of routing streams and telling it where to get. So in this case, this client's saying, hey, give me a stream, give me an edge to connect to, and it says, here's an edge, and then it connects to it, and then the edge starts streaming the video to that client. So another interesting use case here is that one of our clients is doing is a prisoner video chat. Believe it or not, prisoners can do kind of Skype or FaceTime-like experiences through these kiosks that are in the jail. And it's, in this case, the first version of the app that went out actually started getting abused by the visitors or the people that were at home talking to the prisoners, and it kind of became a inappropriate material, or kind of like turned it into sex cams. And so for this one, we actually ended up having to do some real-time face detection and just mask around the face so that nobody could do lewd things. Really funny kind of use case, but actually it was quite a challenge to implement and a lot of fun. And so we've actually rolled out this new feature called Cauldron, which is our processor kind of piece that sits on the server. It incorporates OpenCV, and it can also do like image or video processing in real time to either mask a face in this case, or it can be used for compositing multiple videos together, transcoding to multiple bit rates and formats, doing all kinds of other stuff. But in this case, like I said, it's just masking around the face so that they can't do anything else. So in this case, what they call the visitor stream is coming in from like a smartphone via the app, and then the image stream is coming in from this kiosk device, which in this case actually is a flash, believe it or not. So it's using RTMP to stream in, and then it's basically creating a two-way conversation between these guys with the masking on from this one. And then a person in the jail can monitor the stream if they want, so they can see the conversation happening here. And then once the conversation is over, it'll actually push the recordings to another processing server, which then merges it and then pushes that to data storage. Another cool use case is this kind of geology type surveillance via drones. And working on something that's kind of top secret, so I can't talk too much about it, but I can talk a little bit about the use case, which is just monitoring these monitoring the ground for kind of a railroad type implementation, so that they're flying these drones over. They have these like trucks with this ground Wi-Fi based system, which has a connection out to the internet. It's running a local Red 5 instance on a Linux machine there, transcoding the data coming in from the drone. Transcode is probably not the best word because it actually is H.264 video data coming in, but it's also combining it with this telemetry data and then pushing it out to the various other services. So then it's relaying the stream over RTMP to the nodes in the cloud, and then allowing other people to view this stream in real time, either locally here or out somewhere else on the internet. So, besides the stuff that we make, what are available for IoT developers today for developing these kind of experiences? And I just wanted to go quickly through some of those. There's a lot of client technologies. Intel has its own kind of SDK, media SDK that works with Windows, and I think it actually works with Linux too for doing some media encoding. We have our own SDKs. We have iOS, Android, and HTML5 SDKs that make it pretty easy to build these type of things. We're actually looking at doing a Linux-based one too, so that it'd be kind of easier to make like robot clients and stuff like that. Flash is still quite frequently used. It's classic kind of long tail technology that's still around and still being supported and still being used, amazingly enough. And then there's a lot of low-level open source tools like GStreamer, LibAV, which is a fork of FFmpeg. These are all kind of C libraries which you can use to encode and stream video. And then WebRTC itself is an open source project from Google that you can use on iOS and Android. But it's also built into browsers, so you can use JavaScript to access it and create kind of low latency live streaming experiences. As I had mentioned before, the experience you're watching on right now is actually, you're watching my slides and hearing my voice over WebRTC at the moment. And then server technologies, if you're not doing peer-to-peer, you need a server. And some of those choices are our main competitor, Wowza, us. Adobe pretty much dropped out, but you can still see people using Adobe Media Server today, but I didn't include it on here just because of that. Intel has their own media server. I don't know a ton about it, but I think it's got a lot of features to it, and we've definitely done some projects where they already have an Intel media server working, and they need it to be compatible with ours, and they're relaying RTMP streams to us. Jitsi is an open source WebRTC media server. Same with Janus and Corrento. Jitsi got bought by Atlassian, so they're kind of using it for their internal stuff now. Janus, I think, is the only one that's not, that is still independent, and Corrento got bought by Twilio. And speaking of Twilio, there are hosted platform as a service solutions for doing video streaming, which I think are great for doing prototypes or like kind of MVP or minimal viable products. TalkBox is excellent, really works well. The platform, the Be My App, actually, that we're using right now is built on TalkBox, for example. And Twilio also has these kind of video capabilities which you can use, and they have SDKs. I don't think either of these groups are really focused on IoT at all, but I do think it's probably possible to utilize these for that kind of thing. And you know, there's a couple of downsides with it. One, you don't get much control over the server side, and you can't as easily modify it to suit your needs. And in particular, as you guys probably know with IoT, you're always tweaking something to make it compatible with another device. And you know, when you're locked into a platform, it gets a little bit hard. The other thing is, of course, the hosted model, you aren't really portable and can't move it around. So this is one of the reasons we decided to make our product, you know, not do the hosted model and just do it so our stuff is hosting agnostic. You can deploy it anywhere. And we also have, you know, clustering that allows you to hit massive scale without, you know, yeah, I mean, because one server by itself can't handle that many connections and that much bandwidth. So it's important to offload to other instances to be able to get huge scale on a live broadcast. And with that, we've also built this auto-scale solution. So it's essentially you're getting the value of a platform as a service because you can just let it run on any cloud and it will scale up and down for you as needed. This is a little example of like it's in this state to begin with. You've got two edges running, a live stream going. Lots of people are viewing this. All of a sudden, it gets an event that it tells it to scale out because these two are hitting capacity. It automatically adds another edge, and then it's in this state where you have more capacity here. And then after that, you know, dies down a little bit. The load goes down. It can actually scale in, terminates the instance. The stream manager is managing all of this stuff, and then puts it back into the original state. And this can go down to just having one edge and one origin. That's the basic model for this thing. And right now we have support for AWS and Google Compute Engine. We are developing an Azure implementation, and we actually make the cloud controller component for this open source so that you can manipulate it yourself and create your own if you're using another cloud platform. I'd love to hear from you guys. I didn't want to take up the whole session just talking about our stuff. What do you want to build? And are there questions that I can answer as we go through? Oh, yeah, we have a question from Steven. I'd like to record videos, maybe 2 minutes in length, and save them for later playback. Any particular recommendations? Yeah, I mean, in our system, we actually just have a record flag as part of the stream call. Let me see if I can get a new window up in Chrome and drag it over here. But almost all the different platforms support some way of doing that. So I can show you how we do it, which is probably better to, there we go. So, you know, we've got an HTML5 SDK, iOS SDK. I'll just show you guys how it's done in Android, because Java is a pretty common language and people know it pretty well. Easy to follow. Yeah, if you're going to publish, all you have to do, in our case, well, the specific question is, how do you enable recording? In our case, you actually just specify when you connect one of these three types as a parameter with the stream publish event. So that's a pretty simple, you know, you can tell it to just keep it live, that's the default, or you can tell it to record, and that'll record the stream on the server. And then if you want to append, that means if you already had a file recorded up there with the same stream name, and it would just add to the end of it. So that comes in handy, for example, like when you have somebody drop from a call and then you need to have it come back and add to back to the end of the recording. But in this case, it's pretty simple. You just create a configuration instance with the server you're connecting to, the port. In this case, it's 8554. The context is actually just that's the application you're connected to. So generally, if you're connected to live, and then you can set a buffer time. Usually, if you're doing live stuff, you want to set that very low, like 0.1 or something like that. And then you create a new stream, pass in the connection, and then attach a video source to that stream. So in this case, we're setting up a camera and then pushing this camera into our own R5 camera. You can set the bit rate on it. You can do other things to it, set the orientation. And then you attach that camera to the stream itself. And then you can do the same thing with a microphone, as you'll see down here. Attach a microphone. And then most of the time, people want to create a preview in the phone, so they'll create that view. And then all you have to do is just tell it publish, start that publish. It's pretty simple. And then all the different platforms kind of follow a similar manner of doing that. And just to give you like an idea, see if this server instance is up and running. This is like the console you'd get once you install the server. And then you can do like a select broadcast. This is a little UI for doing this same exact thing. There's me. This is where it would actually put that recording flag in. So we can do that real quick. And I would just do hello, 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 hello from Boston. All right. And then we can either view this in another one. See how bad the bandwidth is for you guys. Yes, Stephen, the question was, am I showing code that would be on an app on an Android phone? That's exactly right. I was just showing an Android implementation as an example. I figured Java was a good language to use just because a lot of people are pretty familiar with it. It's also pretty easy to read. So I can subscribe to my stream. There's my test. Hopefully this won't be chugging too bad because of me doing a live WebRTC broadcast while doing this. See, this is risky doing live demos, man. There we go. Isn't it happening? Oh, I might be running out of bandwidth on my network. There it is. So you see the stream. There it is. All right, and then if I stop this, you should be able to see VOD playback. So see the recording happening. And this was, and boom, we hit a bug. This is a pre-release server, so I should have known better. No dice. But anyway, that's the principle. It would normally work. So, well, anyway, you can find like a ton of examples for different platforms. Not there, not yes. Web5pro.com if you want to check out how to implement a lot of this stuff. And I know there was a session on Android IoT before, and we're actually seeing a lot of people doing pretty cool things with Android IoT devices like glasses. It's a pretty obvious use case because those things have cameras on them and you can live stream that out and do some pretty cool stuff with it. Or as I was mentioning before, some of the other kind of interesting things you can do is using a smartphone as kind of the relay device as well. The other thing is using an IP camera to consume that stream and then push it through the server and then use other devices to be able to view that. And the IP camera could be fixed, or it could also be something that's more mobile, like on a robot. Or an underwater submarine was another pretty interesting use case we've seen pretty recently. I can show my email again, sure. Chris@red5pro.com. You can also see me on Twitter at Mr. Chris Allen. Yeah, I can share these slides. I'll make sure to send them out after the talk. I think the Intel guys will get it to you guys. I'm not quite sure how they do that with this platform. But some of the other cool use cases we've been seeing too, I can kind of go through that aren't just IoT, because I think some of them are at least a little bit interesting. This one, for example, is pretty cool, this Arab idol. I'm not sure if you guys can see it. It's probably not big enough. Basically, it's kind of like this, the experience we're having now, but in this case, you guys probably know the American Idol TV show. If you're American, and pretty much every country in the world has like a version of this thing. And this company, NBC, out of Dubai, does one they're called Arab Idol. And it's the celebrity judges, and then they're judging the singers, and then somebody wins at the end. But during the show, they actually built an app for iOS and Android that allowed the celebrities to live stream from their phones, and then people could watch that via the app in real time. And then the celebrities would pick a person from the audience or not the audience, but out of the people that are on the app, to become a part of it. So it's almost like talk radio for video. And the way that worked is we have one server instance. The celebrity app is connected to this origin, streaming out to a bunch of edges because they have a pretty big audience, and it allowed all of these people to then get selected, and then they get put into this mode where it's actually streaming back up the microphone and camera data back up to this server, and then that stream is being consumed by all of these people too. And because our latency is sub half second, you're able to actually have a conversation in real time with this kind of like, hey, select this caller type thing. And it proved to be a pretty cool experience. And I think a platform like what we're on right now could be greatly improved with that kind of functionality too, if you think about it. Like, instead of Steven having to type his question to me in the chat, we can actually have him just join the broadcast. You can see him as well, and then we're having a Q&A session, and then after he's done, he can step down and then allow another person to jump in and do that kind of thing. So I think there's all kinds of possibilities with that. I think possibilities with IoT devices too really gets to be very interesting with turning them off and on. And we're seeing everything from like surf cams. The surfers want to know what the waves look like before they get there, so they have cameras set up on the beaches, to kind of more surveillance type implementations and all kinds of other crazy stuff. But almost all of them require some kind of low latency experience to be able to really make it work. Particularly with the police body cam one, if you think about it, because you wouldn't be able to actually direct a team if you had a 5-second delay from the stream that's coming back from the police that are on the ground. So that needs to be almost exactly real time. So we've spent a lot of time on making that work, and then also doing it at scale. Well, I guess we'll cut this one a little bit short. If you you guys have any questions for me, once again, my email is chris@red5pro.com. You can hit me up on Twitter as well, Mr. Chris Allen or Mr. Chris Allen. And yeah, that's it. Thank you guys for watching this, and definitely reach out to me if you have any questions or want to build something.